In an electrical panel, a double neutral refers to the use of two separate neutral bus bars or terminals. These are used to connect the neutral conductors from different circuits. The purpose of having two neutral bars is to ensure proper grounding and to prevent neutral overload. One neutral bar is dedicated to the neutral conductors of all the branch circuits that feed loads. The other neutral bar is dedicated to the neutral conductor of the main service entrance panel. The neutral conductors from the branch circuits are connected to the neutral load bar. This bar is then connected to the neutral of the main service entrance panel through the second neutral bar. There are several advantages to using a double neutral configuration. Firstly, it prevents overloading of the neutral circuit by separating the neutral conductors from different circuits. Secondly, it ensures a dedicated grounding path for each circuit, reducing voltage drop and the risk of electrical shock. Thirdly, it allows for easier troubleshooting by isolating circuits in the event of a fault. Fourthly, it helps ensure compliance with the requirements of the National Electrical Code, referred to as the NEC, and other electrical standards. The double neutral arrangement is usually found in larger electrical panels with 100 amps or higher service. The neutral bars are typically labeled as NEU, indicating neutral, and MAIN-NEU, indicating main neutral. Insulated or bonded jumpers are used to connect the two neutral bars. It's important to remember not to connect the equipment grounding conductors, referred to as EGC, to the double neutral. Always consult a qualified and licensed electrician for proper installation and maintenance of an electrical panel. Understanding neutral overload is crucial in electrical systems. Neutral overload occurs when the neutral conductor in a circuit carries more current than it is rated for. This can happen in multi-wire branch circuits where imbalanced loads cause the neutral conductor to carry the difference in current between the hot conductors. In a properly functioning balanced circuit, the current flowing through the neutral wire is minimal, ideally close to zero. This is because the currents from the different hot wires cancel each other out. However, when the loads on the hot wires are unequal, the neutral wire must carry the unbalanced current. A double neutral system helps to mitigate the risk of neutral overload by providing separate paths for neutral currents from different circuits. This separation reduces the likelihood of one neutral conductor becoming overloaded due to the combined currents from multiple circuits. Overloaded neutral conductors can lead to several problems, including overheating, insulation damage, and even electrical fires. Overheating can cause the insulation around the wire to melt or break down, creating a risk of short circuits or ground faults. Damaged insulation also increases the risk of electrical shock. In extreme cases, an overloaded neutral conductor can become a fire hazard, especially if it is located near flammable materials. Therefore, implementing measures to prevent neutral overload is essential for electrical safety. Proper grounding is another critical aspect of electrical systems. Grounding provides a low impedance path for fault currents to flow back to the source, allowing protective devices like circuit breakers or fuses to quickly trip and to energize the circuit. This helps to prevent electrical shock and minimize damage to equipment. The double neutral system contributes to proper grounding by ensuring a dedicated grounding path for each circuit. Each circuit's neutral conductor is connected to a separate neutral bar, which is then connected to the main grounding electrode system. This arrangement helps to minimize voltage drop and ensures that fault currents can flow quickly and safely back to the source. A properly grounded electrical system offers several benefits. It reduces the risk of electrical shock by providing a path for fault currents to flow to ground. It helps to protect equipment from damage by quickly clearing faults. It also improves the overall reliability and safety of the electrical system. In addition to preventing neutral overload and ensuring proper grounding, a double neutral system can also simplify troubleshooting. By isolating circuits in the event of a fault, it becomes easier to identify the source of the problem. For example, if a short circuit occurs in one branch circuit, the circuit breaker for that circuit will trip, but the other circuits connected to the same neutral bar will remain unaffected. This allows electricians to quickly isolate the faulty circuit and begin troubleshooting. Furthermore, a double neutral system can help to improve the overall performance of the electrical system. By providing separate paths for neutral currents, It can reduce voltage drop and minimize electrical noise. This can be particularly important in sensitive electronic equipment that is susceptible to voltage fluctuations or interference. To ensure that a double neutral system is installed correctly, it is important to follow the requirements of the National Electrical Code, referred to as the NEC, and other applicable electrical standards. The NEC provides detailed guidelines for the installation of electrical systems, including requirements for grounding, bonding, and overcurrent protection. It is also important to consult with a qualified and licensed electrician to ensure that the installation meets all applicable codes and standards. When installing a double neutral system, it is important to use appropriately sized conductors and connectors. The neutral conductors must be sized to carry the maximum unbalanced load that is likely to occur on the circuit. The connectors must be rated for the size and type of conductor being used. It is also important to ensure that all connections are made properly and are tightened to the correct torque. Loose or corroded connections can create resistance, which can lead to overheating and other problems. Another important consideration is the labeling of the neutral bars. The neutral bar should be clearly labeled as NEU for neutral and main NEU for main neutral. This will help to prevent confusion and ensure that the correct conductors are connected to the correct bars. In addition to following the NEC and other electrical standards, it is also important to follow the manufacturer's instructions for the electrical panel and other equipment being used. The manufacturer's instructions provide detailed information about the installation, operation, and maintenance of the equipment. It is also important to keep the electrical panel clean and free of debris. Dust, dirt, and other contaminants can accumulate inside the panel, which can lead to overheating and other problems. The panel should be inspected regularly for any signs of damage or corrosion. Any damaged or corroded component should be replaced immediately. Regular maintenance is essential for ensuring the safety and reliability of the electrical system. A qualified and licensed electrician should perform regular inspections of the electrical panel and other electrical equipment. The electrician can identify potential problems and make repairs before they become serious. In addition to regular inspections, it is also important to have the electrical system tested periodically. Testing can help to identify problems that may not be visible during a visual inspection. For example, insulation resistance testing can detect deteriorated insulation, which can be a sign of potential electrical shock hazard. In summary, a double neutral system is an important safety feature in electrical panels. It helps to prevent neutral overload, ensures proper grounding, simplifies troubleshooting, and improves the overall performance of the electrical system. To ensure that a double neutral system is installed correctly and maintained properly, it is important to follow the requirements of the National Electrical Code, referred to as the NEC, other applicable electrical standards, and the manufacturer's instructions. It is also important to consult with a qualified and licensed electrician. A double neutral system is particularly important in larger electrical panels with 100 amps or higher service because these panels typically serve a larger number of circuits and a wider range of electrical loads. This increases the likelihood of neutral overload and the need for proper grounding. In these larger panels, the double neutral system provides an extra layer of protection and helps to ensure the safety and reliability of the electrical system. In addition to the benefits mentioned earlier, a double neutral system can also help to reduce electromagnetic interference, referred to as EMI. EMI is a type of electrical noise that can interfere with the operation of sensitive electronic equipment. By providing separate paths for neutral currents, a double neutral system can help to minimize EMI and improve the performance of electronic equipment. The use of insulated or bonded jumpers to connect the two neutral bars is also an important aspect of a double neutral system. Insulated jumpers provide a safe and reliable connection between the two bars, while bonded jumpers provide a low impedance path for fault currents to flow back to the source. The type of jumper used will depend on the specific application and the requirements of the NEC. It is important to note that the double neutral system is not a substitute for proper wiring practices. All electrical circuits should be wired correctly and in accordance with the NEC and other applicable electrical standards. This includes using the correct size and type of conductors, making proper connections, and providing adequate overcurrent protection. The double neutral system is simply an additional safety feature that helps to enhance the overall safety and reliability of the electrical system. It is also important to remember that electrical work can be dangerous. Only qualified and licensed electricians should perform electrical work. If you are not qualified to perform electrical work, you should always consult with a qualified and licensed electrician. This will help to ensure that the electrical work is done safely and correctly. In addition to the double neutral system, there are other safety features that can be used in electrical panels. These include ground fault circuit interrupters, referred to as GFCIs, arc fault circuit interrupters, referred to as FCIs, and surge protectors. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. FCIs are designed to protect against electrical fires by detecting arc faults and quickly interrupting the circuit. Surge protectors are designed to protect against voltage surges, which can damage electronic equipment. These safety features can be used in conjunction with a double neutral system to provide a comprehensive level of protection for the electrical system and the people who use it. Finally, it is important to stay informed about electrical safety. Read articles, watch videos, and attend workshops to learn more about electrical safety. This will help you to identify potential hazards and take steps to prevent accidents. By staying informed and following safe electrical practices, you can help to protect yourself and others from electrical shock and electrical fires. The National Electrical Code, or NEC, plays a crucial role in ensuring the safety of electrical installations. It provides a comprehensive set of standards and guidelines that cover all aspects of electrical wiring, equipment, and systems. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and to address emerging safety concerns. Compliance with the NEC is mandatory in most jurisdictions. Local electrical codes are often based on the NEC, with some modifications to address local conditions and requirements. The electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations are safe and compliant. They review electrical plans, inspect electrical work, and issue permits for electrical installations. In addition to the NEC, there are other organizations that develop electrical standards and guidelines. These include Underwriters Laboratories, referred to as UL, the Institute of Electrical and Electronics Engineers, referred to as IEE, and the National Fire Protection Association, referred to as NFPA. UL develops safety standards for electrical products. IEE develops standards for electrical engineering and related fields. NFPA develops codes and standards related to fire safety. These organizations play an important role in ensuring the safety and reliability of electrical systems and equipment. When selecting electrical equipment and materials, it is important to choose products that are listed or certified by a recognized testing laboratory. UL is one of the most widely recognized testing laboratories in the United States. UL-listed products have been tested and certified to meet UL safety standards. Using UL-listed products helps to ensure that the electrical system is safe and reliable. It is also important to properly maintain electrical equipment and materials. Regular maintenance can help to prevent problems and extend the life of the equipment. Maintenance tasks may include cleaning, lubricating, tightening connections, and replacing worn or damaged parts. Following the manufacturer's instructions for maintenance is essential. In conclusion, the double neutral system is a valuable safety feature in electrical panels that helps to prevent neutral overload, ensures proper grounding, simplifies troubleshooting, and improves the overall performance of the electrical system. To ensure that a double neutral system is installed correctly and maintained properly, it is important to follow the requirements of the National Electrical Code, referred to as the NEC, other applicable electrical standards, and the manufacturer's instructions. It is also important to consult with a qualified and licensed electrician. Staying informed about electrical safety and following safe electrical practices are essential for protecting yourself and others from electrical shock and electrical fires. Remember, electricity is a powerful force that can be dangerous if not handled properly.